This is just review. If I have y equals 2, guys, pay attention, please. Are you guys all on the right page? 261. Everyone's okay? 261. Stanley doesn't even have his book open.
I have it open.
Okay, I have y equals 2 to the x, and y equals log of x base 2. Guys. Ladies, pay attention, please. Okay, so we learned yesterday that if I have 2 points on one graph, if I have the inverse, I'm switching my x and my y. Inverse is always, so if I have an inverse, it's always a reflection of what line? Y equals x. Inverse is always a reflection of y equals x. So if I give you an exponential equation and I say the points 3, 8 are on it, then I know my inverse, the points are 8, 3. Okay? So if I have an exponential equation saying 8 equals 2 to the exponent of 3, my inverse equation is going to be 3 equals log of 8 base 2. Because all I'm doing right here is switching my x and my y. Okay? Sorry?
You know what Dylan said? He said today's going to be a long math class because his phone's dead.
Oh no, hey? Life just sucks when your phone dies. Okay, evaluating logarithms by converting to exponential form. Kelsey was asked to evaluate log of 8 base 2. Her work is shown below. If I were to put log of 8 base 2 in my calculator, how would I do it? Go the other way around. Yeah, log of 8 divided by log of 2. It's always the log of the argument divided by the log of the base, okay? So that's how you put that in your calculator. Her work is shown below. Study her work to describe each step on the lines provided. So log of 8 base 2 equals v. All she did was set it to v. So that's what this is saying. Represent log of 8 base 2 with the unknown value v. You could use any variable here. Okay? If her next step, 2 to the exponent v equals 8. What did she do here? Yeah, change the exponential form. So we start off with a logarithm, then we change the exponential form. What did she do in this third step? Yep. So change, so set equal, make equal bases. Would that work?
Yeah.
Make equal bases. In questions like this, there will always be a base that would be the same between the two. So if my base was 2 under the exponent, then I want to set the right-hand side to have a base of 2. Okay, so I know that 2 cubed is equal to 8. So all we're doing is writing 8 with a base of 2. Yep. So the third one, v equals 3, set exponents. Set exponents equal to each other. V equals 3.
You know what? I just started a new trend, that's all.
So log of 8 base 2 equals 3. What did she do here? Just substitute your v into your... Just substitute 3 into v.
So is that what you're saying?
So just, you found v here. And now you're substituting back into your original equation. Substitute value. I'm just going to put 3 into original equation. understand these steps? Thank you. Okay, so if you ever have something like that, you could change it to exponential, set your bases equal to each other, bless you, solve for your exponents, and then substitute it back in. So can we do a check for this? What is log of 8 base 2 equal to? Wait for it. So to check it on your calculator, this would be showing your work. So if I say do this on an assignment or something, but you can check it on your calculator, so you can just go log of 8. What the hey? Log of 8 divided by log of 2. And it should be the same. Okay. So if you have to show your work this way, you can always check it on your calculator. Yeah, so on a multiple choice test, just put this in your calculator. Okay, does that make sense? Now we're going to evaluate these using this, but to check your work using your calculator. Because I can do that. Okay. Evaluate the following logarithms. Log of 81 base 3. Okay, let's set it equal to v. Oh, let's just go x. Because if I say stuff about v, you guys are going to laugh. Because, yeah. I'm just going to avoid that altogether. Because I know what happens. What? Yeah, we're avoiding v and d from now on. Those are variables I will not use. Seriously, you guys suck. Okay, so first of all, you set it to a variable. Let's change this to exponential. Perfect. So our bases will stay the same, so it'd be 3 to the x equals 81. Now we have to set our bases equal to each other and then solve for x. So the biggest thing here, guys, at Edgerton, this is what you missed yesterday. So my base will always stay the same. So my base in my logarithm is 3. My base in my exponential equation will be 3. My value, my logarithm is x, so that'll be my new exponent. My argument then turns into my value. Do you guys see where all these numbers are going? Guys in Edgerton, do you understand this? Yeah? Okay. So second one, make equal bases. What is the base we should set these equal to? 3. So let's go.
3, 4, 3, 3. Thank you.
Okay. I can rewrite 81 as 3 to the exponent 4. Yep. So what's my x going to be equal to? X equals 4. Now what do I do? Yeah. So log of 81 base 3 equals 4. Sorry? Oh, you see how my bases are the same here? It's just this one, your exponents, and if your bases are the same, you can set your exponents equal to equal other. So my x will equal my 4. So as soon as you have the same base, you can set your exponents equal to each other. Do this next one on your own. We'll set it equal to y. So follow the steps. So change to exponential form. Set your bases equal to each other. Solve for your variable. And then check your work in your calculator. Yeah. Yeah, it's 3. That's your answer.
I think it's 3 after we repeated it 5 times.
Amanda, seriously, you saying this? You think it's funny, but they don't see your sarcasm. So like, wow.
Amanda says to be on. She just has to get
Yeah, so some people listening, you're probably like, wow, that girl Marlene is so rude. Probably.
I don't care.
Okay, did everyone get 3 as an answer?
Can we do all of them really?
Yep. Okay, this next one, you guys tell me what to do. Let's set it equal to
D.
x. 5. Okay, what's my first step? Yeah, 7 to the x equals 7. This one is, it's easy, but it could be confusing to some. If there's no exponent beside a base, what is your exponent always going to be if there's nothing there? It's always going to be 1, so, guys. So x is equal to? 1. So log of 7 base 7 equals 1.
Let's do D.
You just had to say that, didn't you? Okay, are there any questions with C? Good? Okay. Okay, let's set this equal to x again because I don't want to, whatever, that's fine. Okay, so where do I start with this? What is my base? Where's my base? Your base is always what's under your exponent. What's the base? 12, so I have 12 to the x. I need to write this as 12 to something.
12.
If it's equal to 1, what exponent can I set something equal to so it gets to 1? 0. Anything to the exponent 0 is equal to 1. That's a rule you guys have to remember. Anything to the exponent 0 is equal to 1. So x equals 0. So then your answer is log of 1 base 12 equals 0. Any questions? Nope. Okay, there's a lot to get through, so we're going to try to zoom through it. Okay, so examples above show that the value of a logarithm is the power to which the base has to be raised to equal the argument. You can also just put in your calculator, okay? So there's different ways to do it. Okay, determine the value of log of 1 base b, or log of b base b. Okay, so log of 1 base b, set it equal to x. So let's do the same step we did before. So what is this exponentially? Okay. B to the x equals 1. And then what's my base here? B. So I have b to the x equals, I want this as a base b. What would my exponent have to be to get to 1? 0. So your x equals 0. Okay, so then it would go log of 1 base b equals 0. Okay, set this next one equal to a variable as well. So let's set it to this, put the logarithm into exponential form. So how do we do that? Equals what?
1 and then
Equals b. B to the x equals b. Okay? Yeah, so then if it's just, if I have the same base, if there's nothing beside it, it's always the exponent 1. So x equals 1. So then log of b base b is equal to 1. Okay, so this is, the reason why we do these is because these are general. If you ever have log of 1 base anything, it's going to equal 0. So log of 1 base, so b just is general. Any base, if it's log of 1 base anything, your value will be 0. If you have your argument and your base the same, it'll always be 1. Okay, do you see the difference between the two? So if I ever have the base and the argument the same, it'll be 1. If I ever have, I don't know what that was. If I ever have my argument is 1 with any base, it'll be equal to 0. Okay? So that's what this is saying. Okay. Evaluate here. So this is just throwing that a value in. Okay? So same thing, set this equal to x, or whatever exponent you want, or variable you want. That's fine with me. So to do this right off the bat, should we have this 2 in front? No, we never dealt with anything with the 2 in front, so let's divide both sides by 2. So we have log of 512 base 8 is equal to x over 2. All I did was divide by 2, just to get that x to the right-hand side. Is everyone okay with that step? Okay. Now let's do exactly what we did before. So I start off with my base, so 8. Now we have to the x over 2 is equal to 512. So now we're just changing our logarithm into exponential form. Same idea, we have a base here, and we have another base. Okay, can we change them into the same base? So we have 8, the x over 2 is equal to 8 to the what? Okay, so these just have a couple more steps in. So it's always the same process, it's just a couple more steps here. So now that I have my bases the same, I can set my exponents equal to each other. Okay, so now I have x over 2 equals to 3. So now you want to isolate x, so you multiply both sides by 2. X equals 6. Does everyone get that?
Yep.
Or you could go in your calculator and go 2 times log of 512 divided by log of 8, and it should be 6. Yeah. Okay, so you see how you can check your work here? Okay, let's do this next one. How do I put this into exponential form? Perfect. So this is kind of a pain in the butt because you see how you have a base of 2, and then you have a, bless you, and then you have a base of a fraction. We have to write 1 over 32 with a base of 2. So look at 32. Can we write 2? Or can we write 32 with a base of 2? Yeah, 2 to the 5. But how do I get rid of this 1 over? Do you remember this? So if it's 1 over something, make sure you have that negative exponent. Do you remember this from the first lesson? Come back. So I can rewrite 2 to the x equals 2 to the negative 5. Okay, so I have the same base here. X equals negative 5, so I can rewrite this as log of 1 over 32 base 2. Sorry? Yes. To rewrite this, it would be 2 log of 8, or 512 base 8, equals 6. So you're basically just using your original equation and you're putting your variable into it. Always use your original equation. So we're using this original equation and we're putting that variable into it. Okay. Any questions with that one? Okay, next one. Log of the square root of 125 base 5. Set it equal to x, or whatever you want to set it equal to. Same idea to start off with, okay? So put this into exponential form. 5 5 to the x equals the square root of 125.
I don't know where I pulled that out. My boy is on.
Okay, so up here I'm going to go, I'll put this in blue so you can see. The square root of 125. I can get rid of the square root by writing it as 1/2. Do you remember that?
That's what he should.
So square root, I can write it as an exponent of 1/2. Do you remember that?
Yeah.
So look at 125 now. Can we write 125 with a base of 5?
Yeah, girl. Yeah, girl. God. Are you allowed yourself a man? I know.
So I have 5 cubed is 125, all to the exponent 1/2. What happens if I have a power of a power? What do I do to my exponents? Power of a power, you multiply.
Okay.
So what is 3 times 1/2?
3. That's 1.5. Yeah.
Which should be as a fraction.
Would be 1 and no.
Oh my god.
3 halves. 3 halves. There you go. I didn't even try to do it. I was like, yeah. I was like, no.
Okay, so this is big. I'm just going to go over this again really quick. The square root. You can rewrite a square root as an exponent 1/2. Okay? So these are just rules that you have to know. 125, I have to rewrite as a base of 5. So I know that 5 cubed is equal to 125. But I still have the square root of all that. So I have 5 cubed all to the exponent 1/2. So then I have a power of a power. I multiply my exponents. So 3 times 1/2 is 3 halves. So I will rewrite this as 5 to the x equals 5 to the 3 halves.
I don't get, like, who comes up with these rules? That's just like, okay.
No one just comes up with them. They're
It's
like, you don't make a rule, you figure out what the rule is.
They're like, okay, let's pick the best rule that is so stupid that everyone's just like, what is this? Because I don't get, why do you get, I don't get, like, why don't you just square root it? Instead of putting, because you come up with,
Because we want this 5 to an exponent. Because if you have a square root, let's just say equals, it would be the square root of 5 cubed, right? You can't set your exponents equal to each other here because of that square root. So you don't want to do that. So you know the square root. So a square root is like of x is equal to x to the 1/2. You just have to remember that.
okay.
So if you ever have a square root, it's 1/2. If it's a cubed root, it's 1/3. So it's always this number. So if it's a square root, it's always your index that'll be on the denominator. Okay? So if I have 5 cubed, the square root of it all would be 5 cubed all to the exponent 1/2. That's what 3 halves comes in. Making sense?
Yeah.
Okay. So what do I do next? So what is x equal to? Okay. So now I just put this back into my original equation. You can do a check in your calculator. So go log of the square root of 125.
Too lazy to do it.
And then divide that by log of 5. Enter 1.5, and then you can go math fraction, 3 halves. There's your check. Any questions, guys? Oh my god. Okay, so now let's look at bases that are fractions. Okay, so these are tricky. Okay, so same idea here. You set it equal to x or set it equal to a variable. And I don't want to hear D anymore. Okay, same idea here. Now you set your bases, or change your logarithmic function into exponential. So 1/3 to the x is equal to 27. So there's two different ways you could do this. Okay? You can either set both bases equal to 3 or both bases equal to 1/3. Okay? Whichever one you're comfortable with, I will do both and show you the difference between the two. Because some of you wouldn't like a base of 1/3. Some of you would think that's really weird. So if I were to set this as a base of 3, I would have a negative x. Right? Because 1/3 would be, and then when I have this fraction 1/, if I flip it, I have to have that negative. Equals, and then this would be 3 cubed. Does everyone see what I did there? Or I could do 1/3 to the x is equal to, and then I could set this as a base of 1/3. So this would be 1/3 to the negative 3. Because I know that 3 cubed is equal to 27, but I want 1/3, so it'd be negative. So you guys can do either way. It doesn't matter. This one or this one? The first one? Okay, if I have 1/3 to the x, then if I were to flip this, every time you flip something, so it'd be 3/1, you make that one negative. So if you ever flip something in a fraction and you have an exponent outside, just change your sign. Okay? So if it was 3/2, say it's squared. If I were to rewrite this as 2/3, it's a negative 2. Is that making sense? So it doesn't matter to me which one you do. If you're more comfortable with whole number bases, do the first one. If you don't want to change the base at all, or if you don't want to change the base, you just want to keep one the same, do the second one, okay? You can see they're both the same. You can see both of them, its x is going to be equal to negative 3, okay? Bless you. Okay, any questions, guys? No? Okay, so I'm going to do this next one on another page just so we save room. So 4 to the exponent 1/16 base 4. No. Because you can't square root this. You would have to take the log of 16 base 4's root. Okay. What? So this one, what you do right off the bat is you go, bless you. So you're going to say let log 16 base 4 equals x. Okay, so as soon as you do this, if you set this equal to x, then you have 4 to the x. Okay, so as soon as you have that 4 to the x, equals v, so be 4 to the x, this way. I don't remember doing this last year. Equals v. Oh, no. Okay, we set this here and then we go back. Okay, so now we can solve for this, right? So we're going to solve for this and then we're going to put it back into the original equation. So then we have, then you go 4 to the x equals 16. So to set this, we want the same base. So we have 4 to the x equals 4 squared. What is our x equal to? 2. Okay, so our x is equal to 2 here. So this is where it gets tricky. So our x is equal to 2. We're putting this back into here, okay? So this right here is equal to 2, right? Is everyone okay with that? So this is equal to 4 squared. Are you okay with that?
Yes.
Since all of that is equal to 2, I can rewrite that as 4 squared, which is what? 16. So that is your final answer. So this one, you just figure out your logarithm right off the bat, and then once you get that answer, then you set it, that is your exponent for your original base. Does everyone see what I did here? Okay, do you understand where I got 4 squared from? 4 squared is just equal to 16. There probably will be something like this. What? Oh, crap. Okay, so back to C. Okay, okay, in C, you see how there's 2 things going on here? Yeah, so you find the answer for both of them, and then you subtract it. So let's start with this one first. Oh man, why?
I hate you, don't talk to me.
So log of 1/8 base 1/2. Let's set it equal to x. Okay, so we can solve this. So change this to an exponential equation. What would I get? Wow, you guys are sure sassy towards each other right now. I don't even know what he said, but it probably wasn't. What did you say? She was beaking your town.
I was not.
She totally was.
I said take it away, Edgerton. I was just giving them a chance.
Okay. Same thing on this one. You can either change your bases to 1/2 or change them to 2. It's up to you. What do you want to do? 2? Okay, if you want to do 1/2, do 1/2, but you're going to get the same answer anyway. So if we're changing it to 2, that's what I'll do right now. So if I change this to 2, what will my exponent be? Negative x. And if I change this to 2, what will my exponent be? Negative 3. Thank you. 2 cubed is 8. So what is 8? What is x equal to? Negative x is equal to negative 3. So positive x is equal to positive 3. Okay, I'm going to do the second part down here. So I'll just put a box around that. So I have log of 8 base 1/2. This says it's equal to y. So we're going to say that this is x minus y at the end, okay? So we don't confuse ourselves there. Okay, same thing here. Set this to exponential. How do we do that? Okay. 2 to the what?
What?
Oh, okay. Start off with this one. 1. Oh, yeah, 2 to the negative y is equal to. I didn't use x again because we're solving 2 different things in one question, okay? So what is positive y equal to? Positive y is equal to this is negative, this is positive, it would be negative 3.
Oh, well, yeah.
Sorry, what? Oh, so if you're making it just a base of 1/2, it'd be 1/2 to the y equals 1/2 to negative 3. Does that make sense? Okay, did all of you get x equals 3 and y equals negative 3? Yeah? Everyone in Edge can get that? Just wait, just wait. You got it? Yes, no, maybe? Yeah? Sorry. Allie, what did you say? You got it? Okay, so look back up here. I have log of this minus log of that. So it's x minus y. So let's just take our answers, x minus y. What was our x? Minus, guys, pay attention, please. X minus, what was my y?
Negative 3, so you add it.
Yeah, when you subtract a negative, you add. So your answer here is 6.
Why would you not have guessed that? Oh, I thought maybe a regular.
Well, negative 3 was the answer to your y. Positive 3 was the answer to the x. But the question was this one minus that one. So you take the answer to this one minus the answer to that one. Does everyone see that?
Yes.
Okay.
Did you just say I'll kill you? Yeah. Oh, I'm going to my I hate that. I'm going to pasta. Pizza. Good luck. Have fun. Yeah.
We good?
Yeah.
Everyone has this? Okay. Okay, so we've been doing this the entire time on our calculator. So this shouldn't be too bad. Common logs, you know that if you just go log of whatever, your base will be 10. Okay? So I'm not going to go over that. Logging on a calculator. I'm not going to go over this at all. We've already been doing this all class, okay? Natural logs, you know, natural log, your base is e. So if it's ever natural log, your base will be e. So to evaluate these, you would just put these right into your calculator. Okay, so natural log of 5 in your calculator, just go ln 5, enter. It's right underneath the log. If I have a base of e, I can either go, I'll show you two different ways you can do it. So you can go log of 5 divided by log, it's right above here, so it's your division sign, so just go second divide. Divided by log of e. Or if it's a base of e, it's the same as natural. This is the same as natural log of 5. Okay, so if you don't remember that if you have a base of e, that's your natural log, you could just put it in your calculator like this, okay? So just don't forget to go log of your argument divided by log of your base. What's the natural log of e?
Who knows that? 1. Good try. H1.
Because if I have the argument and the base the same, it'll always equal 1. That was a rule that we had before.
Oh my God, we're still not that.
I'm just going to put that there. Okay, are there any questions with how to use your calculator? Because it's pretty important. No? Okay. Last page. We can do this. Isn't this the last page here? Oh, no, yeah, it is. Oh, man, there's 2 more pages.
When are they gonna get done?
Okay. You know what? We'll be done for today. Do 1 to 5 right now. Where is my, oh, there.